Acha, so next is giant molecular structures. Giant molecular structures. So what is a giant molecular structure? A giant molecular structure contains hundreds of thousands of atoms in one molecule. Hundreds or thousands of atoms in one molecule. একটা molecular ভিতরে there might be hundreds and thousands of atoms joined together. And what are they joined together? With strong covalent bonds. Strong covalent bonds. So due to these strong covalent bonds, giant molecular structures have very high melting and boiling point. So example is diamond and graphite. Diamond and graphite. So diamond and graphite are what are they? They're allotropes of each other. They're allotropes of each other. So allotropes, what are allotropes? Allotropes are
different structure of the same element.
Different structure. It's different forms. Different forms of the same element.
Same element.
So an element exists in several physical forms of the same state. It's said to exist allotrope. So allotrope is different forms of the same element. Example, carbon holo tomar diamond graphite, sulfate holo sulfur holo rhombic sulfur, or ekta ki jani sulfur, I don't remember at this moment. So they are different forms of the same element. Element basic constituent same thakbe, but their structures are different. So diamond. So diamond is a example of a giant molecular structure. So amra jani je a carbon can have a maximum of 4 bonds covalently bonded to each other. Covalently bonded to each other. So amra in a diamond therefore this carbon is bonded to 1, 2, 3, 4. Then this carbon is again bonded to 1, 2, 3, 4. So each carbon is again repeated and 4 carbon atoms are formed. So eventually they form a giant molecular lattice or giant molecular structure consisting of extensive network of covalent bonds. Extensive network of covalent bonds. As a result, a very, very high amount of energy is required to overcome these extensive network of strong covalent bonds. And therefore, the melting and boiling point of diamonds are very high. For the same reason, due to the presence of that extensive network of covalent bonds, they are also very strong. And since each carbon is bonded to 4 other carbon atoms, therefore there is no free electrons. And since there is no free electrons, Therefore, they do not conduct electricity. And এখন you people are already knowledgeable. Diamond কি polar নাকি non-polar molecule?
Non-polar.
It's a polar.
Non-polar.
Non-polar.
Non-polar because all of them are carbon atoms. So will they be soluble or insoluble in water?
Insoluble.
Insoluble in water. See, so conception যদি একবার clear out করতে পারো, you don't need to memorize. You do not need to memorize. So এখন কিন্তু O levels আমরা we memorized যে কেন why they're insoluble, but we did not learn the reason. এখন since now we know the reason, hopefully you do not need to memorize. Okay, so
একটু উপরে স্ক্রল করা যাবে প্লিজ?
হ্যাঁ, so তোমরা বলো, somebody had a question.
Sir, what is tetrahedral?
Tetrahedral মানে each carbon atom is has 4 other bonds, or each atom has 4 bonds and they're arranged in a shape which is tetrahedral. একটা তোমার এরকম একটা মাথা থাকবে আর it's like 3 legs. একটা top থাকবে with, and it has 3 legs, and the angle between them is 109.5 degrees. Angle between each bond is 109.5 degrees. Okay, the shape is tetrahedral. So তোমরা এটা লিখে ফেলো, structure of diamond. Okay, so I'm going to graphite. So graphite is strong, but at the same time it is weak. It is strong individual layer. The individual layers are strong, but between the layers they're weak. Do you get me? আমি কি বললাম বুঝছো তোমরা?
জি স্যার।
So if you think about a single layer is strong. Why are they strong? Because each carbon atom is covalently bonded to 3 other carbon atoms. Each carbon atom is covalently bonded to 3 other carbon atoms. What is happening to the 4th one? The 4th one is used
To conduct electricity.
to form van der Waals forces, or to form intermolecular forces.
Sir, van der Waals are intermolecular same.
So van der Waals forces is a type of intermolecular force. আচ্ছা, so তার মানে আমরা বলতে পারবো যে in the graphite structure each carbon atom is covalently bonded to 3 other carbon atoms, forming layers of linked hexagons. So diamond is tetrahedral, আর graphite is hexagonal.
Sir, 4th carbon atom তো দেখা যাচ্ছে না, মানে linked না তো?
It's not linked. এই জন্য তো আমরা বলছি যে the 4th carbon is free, and due to this free electron, or sorry, not the 4th carbon, but the 4th electron is free, and due to this 4th electron, so if we consider this carbon has 1 bond and a 2nd bond and a 3rd bond. but one bond is still free. One bond is still free, or one electron is still free, which can form a bond. So since the electrons are free, they can move along the graphite structure, and as a result, graphites are good conductor of electricity. Okay, sir. Graphites are good conductors of electricity. So write it down, the graphite structure, and then we'll go to the physical properties. So physical properties of graphite. Physical properties of graphite. Physical properties are mudhe. So graphite has a high melting and boiling point. Obviously we know because it has strong covalent bonds between the carbon atoms. Graphite has a soft, slippery feel because due to these weak van der Waals forces, the layers can easily slide past each other. Graphite has a lower density than diamond. কারণ দেখো ডায়মন্ডে তোমার diamond, each carbon is hexagonally tetrally arranged to another carbon atom, and ekhane per unit volume or per unit area you have more number of carbon atoms, so এই জন্য ডায়মন্ডের ডেনসিটি বেশি.
Sir, but doesn't graphite have more layers than diamond?
Doesn't matter. তুমি একটা চিন্তা করো যে তুমি ক্যান্ডি ফ্লস যে নাও, হ্যাঁ, ক্যান্ডি ফ্লস তোমার ওইটার ক্যান্ডি ফ্লসের ডেনসিটি কি হাই নাকি লো?
No.
Why? Because no matter how big candy floss you have, they're the particles are very distantly arranged. কিন্তু ওই পুরাটাকে তুমি যদি ক্রাম্পল করে দেখবা যে ultimately it comes up to be this. So এর জন্য মানে it doesn't matter whether the layers are more or less, but it depends on how compact the structure is. Graphite is again insoluble in water. Graphite conducts electricity because it has free delocalized electron, which helps to conduct electricity. Okay. Differences between diamond and graphite. So according to property, diamond are colorless glittering crystals used to make jewelry. They're hard, therefore they're used for cutting and drilling metals and glass. Eta copy kore nao.
Wait, sir, what do you mean by does not attack rubber?
অয়েল দিলে রাবারটা চিপকা তো ওটার কারণে গ্রাফাইট ইউজ করা হয়.
Thank you, Abdullah.
You are welcome, sir.
আব্দুল্লাহ আবার বলতো শুনিনি।
অয়েল দিয়ে দেখবি, ঠিক আছে? ওটা হালকা একটু মানে অনেক গ্রিপি হয়ে যাবে। গ্রিপি হয়ে গেলে তোর মেশিন গুলা কাজ করবে না, তো ওটার কারণে তোর এটাতে গ্রিপি হয় না, তো ওটার কারণে এটা ইউজ করে। টেবল টেনিস ব্যাট আছে না, এইভাবে গ্রিপ মানে বুঝছো, স্টেল লাগে।
So silicon dioxide has a shape similar to that of diamond. So each silicon is bonded to 4 oxygens. And each oxygen is bonded to 2 silicon. A pointer is the most important. Each silicon atom is bonded to 4 oxygen. Each oxygen atom is bonded to 2 silicon atoms, which are arranged tetrahedrally. Done, everyone?
Yes.
Yes, sir.
Okay.
Yes, sir.
So why do they have high melting and boiling point? Why, Mahadinur Murshid, why do they have high melting and boiling point?
Because they have a similar structure to that of diamond.
So
এই জন্যই তো, because Because all of their atoms are covalently bonded to each other, hence they have a high melting and boiling point.
Very good. They have all the bonds are covalently bonded. Each atom is covalently bonded to another atom. So they have a strong network of covalent bonds. Therefore, they have high melting and boiling point. Lamisa Sarwar, where is your camera? We put your camera. We won't be asking you to put on your camera every time. Okay, so why don't they conduct electricity? Lamisa Sarwar. Lamisa Sarwar. Nafisa Hassan. Unmute yourself. Unmute yourself.
Because they're very tightly packed together, they do not have any free electrons to move charge.
Okay, very good. So they do not have any free electrons, therefore they do not conduct electricity.
Sir,
Huh.
isn't silicon dioxide a semiconductor?
Silicon dioxide?
A semiconductor?
Silicon
Is
is a
a
semiconductor. Huh?
like
Semiconductor ki silicon dioxide naki silicon. It's silicon. Okay. So next is the difference between a simple molecular structure and a giant molecular structure. Quick. So we already know the properties. There's just the differences in the properties.